We've got 4 speakers this time, so we're really going to be running short on time. Our first speaker is Mr. Dennis Calvert, the CEO of BioLargo. And he says we take some of the hardest challenges because of how our products and solutions are the real deal.
The real deal.
Not the phony deal, a real deal.
The real deal.
and they do with PFAS, VOCs, advanced water treatment, and some of the challenges that they've addressed. And they have multiple patents on all these issues. So Dennis, take it.
Yeah, we're going to be pithy. Thanks everybody for being here. I would really encourage you to take a look at BioLargo. It's a small public company emerging with its first couple of big hits. It took 15 years and a lot of money. It's an incredible journey of innovation. We call ourselves an innovator solution provider, focused on all things sustainable with a heavy emphasis in air and water. And the diversity is remarkable. And we think it's awesome that way. About 4 years ago, we did a deal with an engineering group that was a team that had worked at a 55,000 man firm, Chicago Bridge and Iron, also with Shaw Engineering, if you know those companies. Anyway, a team of people that have been all over the world. And we brought the whole team in all at once because CB&I ran afoul and they laid off 17,000 people in one day. And I called Randy Moore and I said, what you going to do? And he said, what you got in mind? I said, I think we should form an engineering group. And so literally it's like that. So no clients, whole team, all at once. And now these people are shining all over the world. We're winning contracts around the globe, and they've been critical for helping us really scale and develop go-to-market strategies for the innovations that we've invested 15 years developing. We have 8 technologies. It's a multiple platform. PFAS is arguably the largest one in the portfolio. We've got more coming, but PFAS is a big deal. Everybody know what PFAS is? Yeah, per and polyfluoroalkyl, right? So these are non-stick, the derivative fluorine compounds from non-stick coatings. They're dadgum everywhere. It's a problem. And when it's in water, it's really a problem because it transports, it migrates, and it makes it bioavailable. It's an endocrine disruptor. It's been linked to cancer and birth defects. Just do a Google search or an internet search. You'll see it's a massive. We've got an innovation that's coming to market. It's called the AEC. It proposes, and we believe we can defend the thesis that it's going to save everybody a bunch of money, number one, works in a bunch of different types of water, and then ultimately its environmental footprint is 1/1000th the competition, 1/1000th. So what we're doing is we're electrostatically concentrating and isolating the PFAS into a collection system. Once you collect it and you concentrate it without all the other salts, you have an extraordinarily small footprint. That allows you to then manage disposal. Everybody always says, what are you going to do with the waste? We're going to do what the government tells us. Because any other choice is a high-risk proposition. We chose to enter the commercial market as the most efficient collector. We just got our first customer. It's 3 years of work. It's a big one. It's an industrial client. It'll come in 7 to 10 million a year for the next 10 years. And so think of it as like an environmental remediation Superfund site. That's the program. And we have a backlog, national footprint. We've got 45 of the 50 states covered now with national reps, and we're just out of the gate, and it's very exciting. And there it is, and there's a scaled unit. Actually, that's a small unit. Put about 7 of those racks together, you do about 1,000 gallons a minute, right? So it's a building. When you talk about treating a very high scale, it's a building, right? And we're isolating and collecting the PFAS. We've achieved non-detect status. That's a big deal. Non-detect means beyond the level at which science can detect it. These are the units that are now going in the field, so we're doing trials all over the country. Orange County has made public information, by the way, that they expect the budget to treat PFAS in just Orange County with 60 wells at 1.5 billion. 1.5 billion B. We also have micropollutant and advanced oxidation system and AOP, extraordinarily effective at micropollutants. And we believe it has a role to compete with UV as well. Great piece of technology, received over 100 grants. It represents a technical breakthrough, very difficult to get to market. So we don't have commercial clients yet, but we've just completed an 18-month trial in Montreal with a wastewater treatment facility. It's really cool. We have a partnership with one of the leading privately held water companies in North America, Garrett Callahan. If you don't know them, great company. 4th generation, 107 years old. And we developed a treatment system for recycling water cooling tower water. Water reuse, recycling. Great innovation, just now going to market. And of course, we have a 300-man sales force at Garrett Callahan to back us up. So this is really cool. Poof, you got to see this one. How do I get this to play?
This is Poof, the most powerful pet odor eliminator in the world.
I've launched hundreds of products over the last 20 years, generating billions of dollars in revenue. And Poof is one of the best mass marketing products I've ever seen. All the other products that are in the market right now do one of two things. It either destroys the odor molecule with a harsh chemical, or it masks it with a fragrance. We don't do either of those things.
Oh! It's safe for people, pets, and the planet.
Poof eliminates the odor by dismantling the odor molecule. It literally takes stink out of the equation. Poof uses a form.
Let me tell you the story on this real quick. So Poof is just launched in Walmart last week. We've also got 2 major retailers coming behind it for mass market. Our partner has launched about 8 brands that all do $1 billion a year, right, in revenue, like Tide and Febreze and Copperfit and Swiffer, big brands. Okay, so we went industrial, and we paid a price, right? We suffered. But we did succeed, but it took a lot of time, a lot of energy. We became expert. And because of that work, a partner came to us and said, I think you got $1 billion product. I said, we do too. And so we're heading to $1 billion. And I look at that product, and so we have a partnership that's financing all the rollout, and we're the vendor to the project, which means we supply the product and make our money at wholesale. We participate in the exit at 20%. It's an example of over 10 years of work, and all of a sudden preparation meets opportunity. And that's our business. We have a whole portfolio of those. Preparation meets opportunity, the right people, the right spot, and we're in go mode. Poof, make sure you go, P-O-O-P-H. Look it up, watch. Now that you've seen it, you're gonna see it on TV and you go, I know these people. And it's a great testimony to great science, right? And all the things that make it commercially viable now finding the win. So that's BioLargo. Okay? Thank you.
Very quick. Appreciate it. Appreciate it. And we'll do some questions at the end. Our next speaker is Mr. Alexander von Welzek. Am I pronouncing that correct, Alex?
Yeah, Welchek.
Welchek, okay. I put too many things in there. President and CEO of Sky H2O. He's an impact entrepreneur in climate technologies and renewables since 2005, working globally with ESG investors and strategic enterprises to accelerate the sustainability revolution. And a 30-year track record of turning gray to blue infrastructure, enhancing balance with nature. So we're very anxious to hear what you have to say. Thanks, Alex.
Thank you very much. Appreciate being here today. Again, my name is Alex von Welchek, and I'm the founder and CEO of Sky H2O. Sky H2O is a California innovation company, and what we're doing is we're advancing and scaling atmospheric water generation so that it can work well for larger commercial, industrial, and government type applications. Essentially, in a nutshell, we're making the world's largest AWG machines that are truly designed for projects. Atmospheric water generation is considered to be somewhat of a game-changing technology because for the first time, we can produce fresh water at the location where it's truly needed. In other words, the big difference between atmospheric water generation and any and all other water technologies is our resource to make the water is the air and not an existing body of water, enabling us to put these systems at a location where the water is truly needed, including as well allowing us to do this in a way to eliminate costly non-existent infrastructure. So essentially, similar to maybe what solar has done for the energy world, where it's allowed for these distributed generation for microgrids, we believe that as atmospheric water generation now advances, that we're going to start seeing water microgrids at the locations where the water's truly needed. So if you have a mission critical type situation, maybe a hospital, campus, some type of industrial facility, they can now make their own water. Atmospheric water generation, as you pull together a project, there are three elements that ultimately make up your cost of the water. One, of course, is the CapEx. The other one is the operating ongoing maintenance, which is relatively minor. And the third is energy. These systems work off of electricity. The good news is they work off any kind of electricity. And also these systems are very, very smart. So they can be programmed and even remotely controlled to take that energy when the energy is cheap and very available, which is becoming more and more as utilities are going to 50, 100% renewables, where we're having much more unique times of use. So certain times of the day, certain days in the week, certain seasons, energy is getting overproduced, and we can turn that overproduced energy into valuable water. Atmospheric water generation has been identified by GGE Technologies as the #1 climate impact technology for the future. And the industry is still in its infancy, although in different forms. It's been around for a long time, but solar was also around for a long time. But we're now at a point where this industry is expected to grow about 10x over the next 3-4 years. And within that context, Sky H2O is the company that's making the biggest, most efficient systems. When it comes to application of AWG, one really needs to think more refined about water and the water use. There's the water pyramid, and essentially where AWG can do well is providing the water in those, let's say, top 3 areas of the pyramid. Of course, one, drinking water that can be bottled or whatever, that's in many cases very, very expensive water. The water that you would maybe use for cooking, preparing food, particularly in water-stressed areas. And then thirdly, perhaps water that you're using for personal hygiene. The water that you would use to water your lawn, to do big ag, our water is too expensive for. So it needs to be more refined in how you're applying this. Atmospheric water generation is renewable water, similar to the way solar or wind is renewable energy. It works in balance with nature. It's essentially net zero water. And ultimately, because of those characteristics, as well as being able to make that water any place at any time, it's really the ultimate in water sustainability. We at Sky H2O, as mentioned, we are innovating and scaling the industry. What we currently have is the AWG Maximus 4.1. That's our flagship model that we're rolling out. We actually manufacture it here just across the border in Tijuana. We'll be introducing next year to the market the AWG Water Security Tower. So firstly, the AWG Maximus has a rating of 2,800 gallons of water a day in atmospheric conditions. The AWG Water Security Tower will be introducing next year. It'll have a generation capacity about 10x of a Maximus, so about 25,000 gallons of water a day. And then what we also plan to bring to the market is rooftop building integrated, so that a building itself can generate, manage its own water to provide the ultimate in water security. I think that's something that we should be seeing, like at hospitals, mission critical buildings. These buildings today already have to have renewable backup energy. Why shouldn't they have renewable backup water? Sky H2O, we have from the ground up invented our own AWG technology. We did that in collaboration with award-winning professors and scientists, primarily from UC Berkeley. And the key element is that we understand our solution is 30% or more energy efficient than any of the rest. There's further benefits that can come from AWG as we integrate them into projects. Bottling is one of the most popular applications. As you likely know, very often bottled water is selling for $1 a gallon and more. So there's tremendous economics in that. As we're building out the company here from California, we also are already making big inroads in the Middle East and Saudi Arabia, as well as the Mediterranean region, which we actually expect to be the single largest regional market for us in the world, the way that's all set up with the islands and the way these small cities are. Every location works differently, similar to solar or wind. The key driver behind an efficient AWG is relative humidity. Basically, the higher the humidity, the greater the output. So when we try to site projects, we're looking for those locations that have a high value of water, low cost or available energy, and also high relative humidity. We're actually currently building the world's 2 largest AWG projects near Houston, Texas. Here's some examples of deals we're working on: military application in Bahrain. We would like to help free Catalina Island from all of its restrictions, which is really water. We can make water there. There's a number of facilities in southern Texas who are looking to go net zero water. Great applications there. Very often these waste to energy facilities have a hard time selling the energy. We can turn that undervalued energy into valuable water. We're looking at doing that in Monterrey, Mexico. Emergency relief is a popular application. The systems can be mobile. Malaga, Spain is a beachhead into Northern Africa. And like I said, what we're rolling out now by Houston are what we call Sky H2O stations. These are gas station type looking, but they're water stations. And in fact, BioLargo is going to be providing the water processing on these systems that we're very proud about. And that's the footprint of it. One of these is going to be generating about 30,000 gallons of fresh water a day. And we're looking to roll out about 100 Sky H2O stations over the next 4 or 5 years, including a couple here in the San Diego area. So I think that's kind of a wrap, and I can be available for questions.
Sure. Thank you, Alex.
Thank you.
Gil mentioned Singapore, and I've spent a bunch of time in Singapore, and they certainly have a need. And that is a humid place. And I would think every building in Singapore would need one of your units to make water, and I think it'd be an ideal market. Yeah, it makes all kinds of sense. I've never sweat so much in my whole life as in Singapore. Yeah. Oh, well. Our next presenter is Subir Bhattacharjee. How did I do, Subir? Close? Pretty good. Close, okay. He's the founder and CEO of IntelliFlux Controls. He worked in water management and reuse for 3 decades. And in his own words, he's working with an ACE team to embed the process engineer part of his brain into an AI-based software platform for process automation. Now, as I think about that, if you succeed, won't you be out of a job? Good point. Come and tell us about it.
Thank you very much, Randy. And I think it's better that way because that part of the brain comes without the personality. So getting into the crux of what we do, IntelliFlux Controls is trying to redefine the human-machine relationship in process industry. We are doing it through a software which is called Apricot. The function of this software is to include all aspects of process intelligence. That means all of the information, data, knowledge, and wisdom in a process plant to be integrated into a singular platform and then deploy it for the benefit of the operators and engineers and managers of the plant. A not so fancy way of looking at this category of software is what you call asset management software. But we very much focus on process industry verticals. The problem we try to address is an extremely poignant and important problem that I see across the world in process industries. Manufacturing environments are becoming technologically complex. Every water treatment plant I see looks like a Rube Goldberg system. There are a bunch of processes tethered together. It is not a box. It's not a system like a car. The systems are very complicated. They work together. It's a magical thing. However, they face unprecedented shortage of qualified operating personnel. Of any time in the past, this is the first time industries are facing this problem in a pretty major way. On one hand, companies are global, so they are manufacturing in diverse socioeconomic conditions, profitably, reliably, and responsibly. ESG is a big buzzword, and everybody is talking about social responsibility of manufacturing. That is pressurizing businesses. But on the other hand, when you get down to the real manufacturing operation, there are fewer experienced operators, and the new workforce is possibly lacking skill sets. They are very smart, and so I won't put that as an important thing. But the thing that's more important is they are lacking motivation to work on shop floors. Ask any new generation kid, they do not like to work in the operating environment. This is where we are trying to figure out a way of completely reimagining the human-machine interactions in the plant operating environments, which is critical for sustainability of your manufacturing businesses and manufacturing assets. And in water, where we have worked, I'll show you a few examples. So IntelliFlux Controls is digitally transforming process industries with its platform called Apricot. We combine digital twins, which are models of the actual processes in the plant, with AI, assisted automation, along with our engineering knowledge and skill set in process industries to revolutionize how process plants are managed and operated. Apricot is a platform to deliver process wisdom. This is one bracket of AI or intelligence, and it's one of the highest manifestations of intelligence is what we try to achieve. To adaptively operate and optimize process plants in real time, and we sell this product at 3 tiers. The lowest one is essentially a global connector for process plant information. It's a glorified SCADA. However, the other 2 embed higher level functions, which I will talk about a little bit. I'll do that through examples. So here is an example of a water treatment plant where you have a membrane bioreactor following an upflow anaerobic sludge blanket reactor. And in this particular system, keeping the membranes alive and working, though they are ceramic membranes, was a nightmare for operators. We put in something called Apricot Operate to automate the cleaning of these membranes. This is sort of visible through, I hope there is a pointer, but no. You will be seeing this through these yellow circles that dance around. They are different intensity or different ways of cleaning the membrane that dance around inversely to what is the quality of the feed water that's coming in. Bad feed water, membrane gets more dirty, you clean more effectively and aggressively. But good days, clean water, you produce more water, do not disrupt the cleaning with harsh cleaning, you clean more benignly, you increase the life of the membrane. But the most important thing we did here was increase the uptime of the plant by 80%. The plant was down a lot because people had to wait for CIP, etc., but we changed that quite dramatically. We lowered the rate of membrane permeability decline by 75%. Not a good news for people who sell replacement membranes, but pretty good news for the plant. We saved OPEX, which is primarily energy, by 16%. Another example, sewage treatment plant, which treats municipal sewage and discharges it into the river Ganga. And in this plant, we provide Apricot Connect and Assist, which provides a digital twin-based guidance to the operators about how to manage and tailor the operation of the biochemical reactions in the reactor and the UV system to keep it continuously operation as the feed water quality and quantity changes. And that feed water in India in rainy season can be quite fluctuating. We are seeing energy savings at about 2 megawatt hour per day for this plant, which is about 120 million liters per day. This is an interesting application, an oil and gas upstream facility, gas, oil, water, all being handled, about 100,000 barrels of oil per day and about 1.6 million barrels of water per day being handled in the plant, 49 unit operations connected together. Whenever a problem happened in this plant, operators would typically go back to software like Aspen HYSYS and do process simulation and troubleshoot it over a month. This is almost like embedding a process simulator for these 49 unit operations that do that calculation automatically every 6 minutes. So the people are being alerted by this software if there is any anomaly in this complex plant. And this is being applied to manage energy at this site. Wherever we have gone, we are very value-based priced. So savings in clean water use, savings in energy use, more employees working remotely and can manage the plant from anywhere. And whenever we have a membrane or filtration plant, increase the replacement time of the cartridges or media replacement or the membrane replacement are the basis of us acquiring value from the customer or getting paid by the customer. What we do to manifest that intelligence is very simple though. Normally, what human operators do in a conventional process is close something called the IDKW loop: information, data, knowledge, wisdom. And how human beings do it when a problem manifests is you will detect the problem, you will go around collecting the data and the information that will help you analyze the problem. You then become an Excel warrior in the modern day. You will crunch that number in many ways to synthesize the solution. Then you will find the root cause, you will socialize it with your peers, and then you will find a solution. That takes time. Every problem troubleshooting takes time. What Apricot does for customers is does the grunge work and the detective work almost instantaneously. We are tethered to the plant automation system, detect the problem instantaneously, and even a multiple unit operation system, we detect upstream problems and tell people 6 hours ahead of time something is coming your way in the RO system. So we do the information data gathering in the background, the software is doing it. Data to knowledge conversion, instantaneous. However, we leave for the humans when we do Apricot Assist to do the highest faculty tasks that a human being loves to do. And that is think, be creative, and come up with a solution, and you feel good and successful. And when you tie this to a social media-like platform, we call it our community platform, it does magic. We have seen top-tier scientists of the company who are talking heterotrophic bacteria and autotrophic bacteria doing things with the electrical engineering operator simultaneously exchanging notes on the same platform and giving instructions and help to each other. And the problem troubleshooting time comes down because a system needs to be managed by a system of people who are not working in silo. It breaks the silos between different engineering departments. So that is what we do. But in a nutshell, what we do with Apricot is it is a software portal that helps you jump from data to an actionable wisdom at warp speed. It happens all the time when we connect ourselves to your plan. Thank you very much. And if you are interested, I would appreciate it.
Very good. And I'm glad you're not going to work yourself out of a job. We need your personality involved. And we'll have questions at the end. And it looks like we'll have time for questions, so that's very good. Our next speaker is Mr. Eric Trerotola, and he is the sales manager in North America for Asterra. Asterra does satellite-assisted leak detection analysis of distribution systems. And I wrote down in land risk because I saw that on your website. He said leave out land risk. But land risk is important to San Diego because our bluffs are falling into the ocean, and we're going to have to change our train line and all that sort of stuff. That's part of what you guys also do, I think, that sort of analysis. So Eric, we're happy to hear what you're going to do.
Excellent. Thank you. All right. So as Randy said, I'm the sales manager for Asterra. Just last year, AWWA, which is not the governing body, but the association, gave us the very first ever innovation award for us. And so we're very proud, even though we're a relatively new company, something we're very, very excited about. A little bit about Asterra. Our founder was part of the project that found water on Mars. They did find water on Mars. They found it 5,000 feet beneath the Martian surface on the southern pole. And it got our founder to start thinking, I wonder if we can do this technology here on Earth. He's from Israel, and it's a desert. And he's like, I wonder if we can do that. So that was really the genesis. That was in 2013. Since then, 2016, we had our very first project, and now we've done almost 700 projects worldwide, 64 countries, and we have offices, and then our production and R&D is in Israel. Our California, our North America base is right here in San Diego. And we've helped save over 210 billion gallons, 57,000 leaks verified. But the one thing that you can really take away from what we do is we make leak detection teams far more effective. This figure here of 1.3 leaks found per day is what pro leak detection teams, they're some of the best trained people. They do it all the time. They have the best equipment. They have the best ears. Their 10-year average is 1.3 leaks found per day. Our worldwide benchmark is 3.5. Most utilities are nowhere near 1.3. A matter of fact, I'll show a case study that really just a fraction of that. So for us to have a worldwide average using internal utilities to 3.5 leaks per day is a pretty good deal. So how are we doing it? Well, we're using what's called synthetic aperture radar. And we're using 3 different commercial satellites. They're in a polar orbit. So basically, every 90 minutes, as the satellite's going around the planet, the Earth rotates, and that's how we're getting our coverage. Some of the advantages of a satellite is every 14 days, we can scan the exact same area, exact same angle. Because it's in space, the satellites we use are about the size of a bus. So we can put a lot of robust sensors on board. As I mentioned, every 90 minutes, these satellites that are at 390 miles in space are circling the Earth. And data is relatively cheap because we can cover, again, we're from space, so we can cover a pretty large area. How large? Well, this is the San Francisco Bay Area. Not only can we scan one system, one utility, but oftentimes we can scan multiple utilities within one scan, up to about 1,400 square miles. And how we're doing it is just using radar. Synthetic aperture radar is just regular radar or sonar. Basically, we emit a signal and we get the return back. It's just that simple. Some of its capabilities are being able to see at night, 24 hours a day, 7 days a week. We can see right through clouds. We can see through foliage. We can see through concrete, asphalt, everything but metal. That's the only thing we can't see through. And because we're using L-band, we can penetrate the ground. So we can see up to about 10 feet beneath the surface. The more arid the ground, the deeper we can see. We've done projects in Oman where we could see 30 feet into the ground. So we can see, in most cases, distribution lines and everything are well within that 10 feet. And also the satellite and the technology is extremely sensitive to water. So we see all types of water: groundwater, raw water, reclaimed water, wastewater, as well as potable water. All of this technology, being able to see at night, being able to see through clouds, you probably think, I wonder, that sounds very military-like. And we're actually on a military base now, an old military base now, so it's very fitting. And you'd be absolutely right. This technology is nothing new. It's been around since the 1950s. But really, our analytics are what brought this to the forefront. And a lot of our heavy lifting is really overcoming a lot of the limitations within SAR. We live on a very noisy planet. The operating range is between the 1 to 2 gigahertz range. That's airport radars, Wi-Fi networks, cell phones, microwaves. It's endless. Our founder said it was actually easier to find water on Mars because it was a pristine environment. So a lot of our heavy lifting is literally just cleaning up an image. Geometry, curvature of the planet. Again, we're from space. So if you've ever tried to draw a 2-dimensional map on a piece of paper and then wrap it around a globe, you'll know things don't line up. So a lot of our stuff is making sure everything's geo-referenced. So when we call out, we see a leak, they go to the place and it's actually there. So a lot of this is really what makes it something that we can do now. So this is a synthetic aperture radar. Honestly, it looks like maybe someone left the TV on too late. Some of that interference is right here, some of that white stuff. So we've got to clean that up to get below it. Honestly, it looks like the Matrix to me. But what we're actually looking for is the conductivity levels of different elements. And this is as geeky as I'll get, but basically this is a dielectric properties. It's basically the ability for an element to conduct electricity. Everything has a very unique dielectric constant. Air is 1, dry sand is 5, saturated sand is 30, very dynamic, very unique. Our challenge is all types of water is about 81. So because we're on a wide wavelength, we're able to expand that out to where we can start differentiating the difference between seawater, sewage, and potable water. So that's the other part that we're doing. So a lot of utilities, what they do is, honestly, they just wait for something to surface. And that's basically their program. They wait, it surfaces, they get a call in from a client or a customer, then they go out and then they fix the leak. The problem with that is only 50% of the leaks ever surface. So we're really skipping out on a big opportunity to save water leaks. We see these three gentlemen. This is the most proactive leak detection method, is basically walking the system. And we see these three guys, and we can laugh at them because, look at they're listening with listening sticks, and we can say, wow, we've really come a long way. But the premise of what they're doing is exactly what we're doing right now. That is blindly walking the entire streets, listening to hope they can find a leak. Now, nowadays we have electronic equipment. It's actually much heavier nowadays, so it's actually even more of a burden for them. We can listen a little bit better, but honestly, most utilities just give up. It's so inefficient. They're not finding leaks. They just give up and they just wait for things to surface. So what we do is we are able to scan an entire system, isolate 5 to 10% of the system that where we're seeing the potable water leaks, or if they're interested in wastewater, we can isolate that, and then send those search crews to that 5 to 10% so they're not walking the entire system. Is basically how that's working. Just kind of going through some of our projects. This one was a leak that we found. It was on a 16-inch line, zero evidence. It was not surfacing at all. This 1 year savings was over $112,000 for just one savings. Again, it wasn't surfacing. It would have persisted for probably years. This is a really interesting one. You can actually see kind of a Google Earth archived image of a blue lagoon. This was at least for 3 years, easily could have been 4 to 5 years. It was 700 to 1,000 gallons per minute leaking. The general manager there said if it wasn't for us telling him where this was, and this was in the middle of a tidal marsh. So we found leaking potable water in the middle of a tidal marsh. It was causing them $500,000 a year. And like I said, from the Google Archive image, we know for at least 3 years it was leaking. So easily could have been 4 to 5 years. And then lastly, we've got this leaks found per day. I was mentioning a lot of utilities. This is in New Braunfels, just outside of San Antonio. They're at 0.06 leaks found per day. I said the pros are at about 1.3, and a lot of utilities are nowhere near that. This is a good example of that. We helped the exact same crew find 4.1 leaks per day. So they really knocked it out of the park. Again, just guiding them to where the leaks are. The previous year, they found 16 leaks. With our guidance, they found 229 leaks. So just making them far more effective. And it's not just the water we're trying to save, it's the heating, the treating, and the pumping of water, all of that energy that's tied into that. So if we can get more efficient use of our water, we save not just water, but the energy itself. And basically, just in summary, it's non-invasive. We're just tracking the water. We have the ability to track infrastructure, pipe replacement, and it's by far the most cost-effective way to support regulatory compliance. And that is basically it in a nutshell.
Thank you, Eric.
Yep, you guys drank from the fire hose.
Well, we have plenty of time for questions and lots of microphones. I will start with one question for Subir. Subir, your technology, it seems to me, requires good sensors that give accurate data into the system. And one of the things in the early days when I was messing around with R&D and reverse osmosis and water treatment is we had a hell of a time with good sensors or keeping them clean and functioning. Now, I think things have improved remarkably since then, because I'm talking about 30 or 40 years ago. So does that make a big difference? And has there been a big improvement there?
You're right. Good sensors will improve the quality of the data and the information. However, in these types of projects, when we try to put in water quality sensors, they are so expensive that they are out of the range for most of our retrofit customers. A UV-based sensor to be put in to measure COD is at the range of $24,000. You cannot do this. This is where IntelliFlux's approach is based on digital twins, where we are connecting the laboratory information management system, or the LIMS, so that the lab measured data is directly integrated with the SCADA. Now what we are doing is time correlated data That is allowing us to get a semblance of accuracy in our model and verification of the data. I hope it answers your question. I wish sensors were available at a price range, right? Pressure sensors. Flow sensors are expensive, but vibration sensors in motors, for instance. This is an important area of research. And if it comes in as inline sensors that are inexpensive, we will change the world with respect to reliability of water treatment systems.
How quick a feedback cycle do you get from the analytical labs? Do you have to push them to get the analysis done and put it into the system?
Very good point. Not more frequently than once a day. With respect to sensor data. This frequency, however, is a very important thing that differentiates our product, why we are pushing full automation or decision automation over supporting operators. So we can generate instructions for operators to say, do a CIP in the next 6 hours, to do a CIP every 72 hours. But when we are doing it in a decision support mode, the operators will typically do it at 9 a.m. every day. So the value proposition of decision support, when you tell the human has to do something, it has its own disconnect with the implementation of digitalization. These are the nuances that you learn when you go to the field and see the actual operation. And this is why we were very much under the radar until we got operational data in real working plants. These examples I showed are actually real working plants. And the problems on the human side are enormously more intractable to fathom than the technical problems. All technologies in 21st century work pretty well.
Do you call this artificial intelligence or machine learning? Or both?
It is, there is machine learning embedded in our software. We combine the digital twin, which is purely a process simulation of the exact process. So that part is very physics-based. Now that is mapped with machine learning, or quote unquote, one subclass of AI that captures all of those random events, weather, temperature, biological processes. Temperature goes below 15, this tank has foaming. So we are using machine learning to get two parts. One is the human operator, and the other part is the weather and other anomalies. It's very, I mean, I may sound very insensitive when I say this, but you need AI to actually understand human interactions with machines. The machine part or the design part is very well done by engineering analysis.
Okay, thank you. Other questions? And please state your name and affiliation.
Hi, I'm Shannon Lopez with Hydronautics. I have a question for Alexander. You mentioned in one of your slides that you were looking at using the atmospheric water collection with waste to energy applications. Is that through the combustion method, or I guess where in that application are you looking?
So these systems, they run off of electricity. We require we require electricity to run the machines, and you know, kilowatt hour is a kilowatt hour. We prefer that it comes from renewable energy, but it can really come from any energy source. And what we're seeing often on these waste to energy projects that are often a very multifaceted business model. They get tipping fees and all kinds of things. We often see, and we're seeing this in Mexico, where there's challenges with the local utility, where they are doing a waste to energy project, but they can't sell the energy. You know, CFE is not taking it. So they literally flare it off, or I don't know what they do with it. So now they're looking at putting on the back end of it AWG, so at least they can make something valuable out of that energy that they've created. Water.
Another question? And name and affiliation.
Thanks, Randy. Greg Murphy with Blue Economy Strategies. A question for Eric. As a sales guy, I can imagine how many scenes that you find where there's a municipality that's leaking and they're not a client. So what do you do in that situation?
That's probably our biggest challenge, is trying to sell them on what we can do and how we can help them. We hear all kinds of objections. We have more leaks than we can fix now. They're surfacing already. We can't, I was in one in the Midwest, a very large system. I won't embarrass them, but they literally said they can't fix the leaks they have. So showing them the technology and showing them, you may be short on people, but showing them how we can make them far more effective. Leaks are going to happen. They don't fix themselves. They either persist or they become a giant sinkhole. And Murphy has told us with his law that they don't happen on 9 to 5. They typically happen New Year's Eve, Christmas Eve at 12 o'clock in the morning. So showing them how we can help them find those, do scheduled leak repair versus emergency leak repair, and they start to see the light. But there are some of them that just, we're good. But that's our biggest challenge, definitely. You hit it right on the head.
And then follow-up question for Alexander. Are you finding, can you talk about any pilots that you're doing with building infrastructure with AWG?
With building infrastructure?
The building, the last business case that you had within the building.
So that's a, if you will, aspirational project we have in the drawing books.
Okay.
As we build out the company, we're going to be introducing rooftop building integrated, hopefully by the end of next year. We are in discussions with a number of real estate type owners, operators who've expressed interest in this. We've kind of socialized it to see, is there a market? We said yes, and that's what we're going to go forward, develop that in our development.
That's great. Thank you.
For Asterra, interested in infiltration. A lot of wastewater facilities get more water than they thought they were going to get. So that's the opposite of a leak.
Yep.
Can you monitor that? And
we don't see the pipes at all. The way we work is we see water leaking into the system. We see the saturated soil is what we actually see. And then once we lay over the GIS data of a system's leaks, that's where we signal the points of interest or likely leak locations. So to answer your question, no, we can see extrusion on the high force mains, not intrusion. But you're absolutely right. Yeah, that's another big problem. The community definitely feels extrusion is the biggest deal. But as far as a plant operator and they're being charged to treat so many gallons, intrusion is very important for them.
But it still potentially gives you you're right about people have a route. They go check the whole system once a month. They do these 5 streets today and keep rolling. And if you can give them some anticipation of where to go, start looking, it's a big
exactly.
savings.
Yeah, if we can highlight 5 to 10% of the system, then there you go. Yeah, they don't have to do it. And with staffing nowadays, it's very tough. So
I like it. Thank you.
Thank you.
One more, Shannon.
I'm sorry, I'm hogging it. This is a question for Dennis. So you mentioned that you have a method that you're using to filter PFAS and that they were below detection level. My question is it for just the PFAS chemicals that are currently being looked at, or are you looking at the widespread of it? I know some of them, there's different challenges with at least adsorption media due to the electrostatic nature of the surfactant. And so I guess I'm asking, is it a wide range that you guys can capture, or?
Yeah, we've tested about 29 of PFAS, mostly focused on the highly regulated and toxic ones that are labeled, where the federal mandate is moving into CERCLA and hazmat status, because those are the hot ones. The system, though, is indiscriminate. It's going to get the molecules that have that charge and have a fluorine compound bond are going to be attracted to the membrane for collection selectively. So, so that's the answer. So it's like 29 sample constituents so far in our panel. There's a lot of work going on about extending that into more and more. It's just a money thing, right? How much money you want to spend? How deep do you want to dig into the data? From our perspective, the market is really demanding the focus on the ones that are highly regulated. That's the most important today. And then our first customer is a replacement for carbon. And so most of the systems that have been installed are ion exchange or carbon systems, which are really problematic. They're not going to reach the ultra low detection limits. They have a channeling effect, and then they have this waste stream that's astronomical. So in our first project, they've got like 15 trucks coming about every 13 days to pick up all the carbon. I mean, it's unbelievable. And it's just not tolerable. It's not sustainable. So they're looking for a way to super concentrate and then ultimately dispose or destroy. So we think it's a great spot. Yep.
Eric.
I have a follow-up question. So you're on the PFAS removal, you said it's electrostatic.
Yeah.
So how does your media or surface?
Membrane. Yeah. It's membrane across an electrode. So we've got a channeled electrode. It's a panel, like a plate and frame. As water flows through it, the PFAS is migrated to its opposite charge. It binds to the surface of the membrane and collects. And so it's uniquely situated to collect the fluorine bound.
So I mean, PFAS is either carboxylic acid or sulfonic acid, which is the charge functional group. So how does your membrane distinguish between other anions, like sulfate or
So the
chloride?
salts are passing through the membrane. So it is a selective extraction. Yeah.
Interesting. And then what do you do with
On the disposal side?
Yeah.
So we offer our customers a membrane exchange, right? So we're the collector and the disposer as well. So that creates another recurring revenue stream, which we think is really important. On the destruction side, our team are experts in destruction. They've got 30 years of career, right? So you name it, they burned it. I mean, really interesting careers. And we do disarmament at Picatinny Arsenal and, amazing projects, waste energy, all kinds of stuff. Anyway, so there's a whole number of ways, right? And there's a number of technologies in that space: enzymatic, plasma, pyrolysis, incineration. All of the above have some role to play. Our thesis is whatever one the government says, that's the one we're going to do. I mean, because really, if you think about it from an economic risk tolerance perspective, until that decision is made, everybody's at total risk of their decision. And we can't tolerate it. We looked at it and said, that'll put us, it has the potential of putting you out your business if you choose wrong. So our attitude is let's wait to see what the regulatory front really points to on that. And now we've done a ton of work in the waste handling side as landfills as well. And so we're working on some advanced techniques for leachate, which is even a whole nother, massive problem. I mean, it's unbelievable. So we're working on advanced technologies for the destruction of PFAS in a leachate stream and solid waste. I mean, it's an emerging field. We think the market for the PFAS is about a $60 billion a year market. And everybody's trying to find an answer, especially with the regulatory news tightening down to 1 and 2 parts per trillion. And so the way we say it is, it may be the contaminator of the century, not just the decade, number one. And everywhere you go, the quote, politicians are saying, this is going to be with us, quote, forever. This is not a 10-year fix. This is 30 years, maybe, because it's been so widely disseminated. So I hope that answers the question.
Yeah, thank you.
Time for probably one more question, if we have one. Anybody? Thank you, Mark. Yes. Juliana, right? I'm learning.
Hi, Juliana Porres Mendoza with Calvert. All of the technologies you all talked about are actually very interesting, very different places, filling gaps in a lot of areas in water. What are the biggest challenges you see entering markets, especially in the municipal sector? Water is very risk-averse industry, and you can tell them, yeah, I can solve your problem, and they're never going to believe you. So what are some of the challenges, and how are you kind of going through that market as you try and really introduce these new technologies and telling everybody I could do better than what you've been doing forever?
You want to start, Dennis?
Yeah, short version. One of our assets is the AOS and AOP. We've got about 8 years, almost 6.5 years invested. I mean, it's crazy. And I remember sitting with the head of the EPA ombudsman, Sally Gutierrez. If you know Sally, she's awesome, right? And she said, Dennis, whatever you do, make sure you have something else that's making money. I'm like, oh my God. Right? And so what we did is we diversified so that we could continue to innovate and look and focus on purposeful innovation for water, even though the adoption cycle is so long. The second thing we did is we went vertical to become a solution provider. So a solution provider is a different game than selling widgets, right? And so that combination makes it a powerful selling proposition at the marketplace. And the third is we lean heavily on clusters like TMA. We also lean heavily on federal funding wherever possible. So that AOS has received 100 grants. It's over about 4.8 million. And we needed every penny of it, and more, by the way. And so I think that you've hit the nail on the head with the extraordinary difficulty to be an innovator in a highly regimented, old school market that has very low tolerance for risk. The other thing, yeah, right. No, We get it. We get why, right? The why is certainly understandable, but nonetheless, it means that innovation is thwarted, right? Unless there's some kind of cooperation. I had a chance to do the Metropolitan Water District, did a call for innovation. I mean, what an incredible thing to sit there and listen to all the engineers talk about the things they couldn't solve. And that kind of outreach by industry is so valuable to entrepreneurs trying to figure out how to serve it. And the other one last piece is that we lean heavily on the industrial side. So I remember being told again, which we've learned, is some of the industries are so wealthy, they don't have time to screw around. I mean, pardon my language. They don't want to mess around. They want to go and they want it now, and they'll take risks to get it. And so when you present yourself as a solution provider, then choosing technologies to hit the target, they adopt faster. And so that's how we've done it. I'm not saying it's perfect, by the way, but it's a multi-pronged. There's no simple answer.
Alex, you want to weigh in?
Yeah, sure. So we at SkyHO, for the most part, are avoiding municipal piped water type applications. From our perspective, generally water is undervalued. The municipalities really don't pay anything for it. They expect it for free. On the other hand, commercial users of water, particularly consumers of bottled water, pay an amazing amount of money. It's kind of crazy. Municipalities, they essentially have no money to do a lot of these things that they need to do. On the other hand, these groups like Coca-Cola and Nestle and others that are Fiji, they're shipping water around the world and selling it for well over $1 a gallon. They're making huge amounts of money. So our model for mostly that we're pushing is what I showed you, the SkyTrip stations, which is essentially a model where we circumvent the municipalities, but we undercut the existing bottled water providers with if you will, a micro watery type situation. So we have a business model that's highly profitable, but it's only highly profitable because we're hitting the consumers and the commercial businesses who are willing to pay a much higher price.
I think that's a good place to stop, but I will give you a quick summation. All of these new innovative technologies start in the industrial sector, and once they're proven and have worked well, and they've got the data and the economics and technical papers and everything else you need, they can go to the municipalities, then you have a chance. If you try to start with your municipalities, you've really got an uphill slog, and I don't think you're going to make it. So with that, we're going to end this session. This is panel 2. We will have panel 3 at 1 o'clock.